Linked list, like arrays, is a linear data structure. Like arrays, it stores the items in sequential manner, one after the other. But unlike arrays, elements do not have to be at contiguous location in linked list. This is the major difference, right? In arrays, everything has to be at contiguous location. Whether it is dynamic sized array or fixed size array or variable size array, everywhere elements have to be at contiguous. In linked list, they do not have to be contiguous. So every node stores reference or pointer to the next node, right? They can be anywhere in the location in memory, but how are they connected? They store the reference or pointer of each other. That's how they form a sequence. So if you have your memory like this, your memory can be seen as an array of bytes, right? So some bytes required by the first node. This is how they are connected in memory. So it has the value here, then it has the address of the other node, then it has the address of other node, then it has the address of other node, and last node's next is null. The next node for the last is null or empty, right? So that's how they form a chain or sequence. That's how they store the data. They store the memory addresses of each other or references of each other. So when I say memory address or pointer, I'm talking about C or C++. When I say references, I'm talking about Java or Python. There we do not have pointers. We store references to connect these nodes together, right? So this is how linked list is in memory. This is a pictorial representation. One important thing, if this node is addressed 2000, and what used to happen in arrays, if this say single node takes 8 bytes, then in arrays it had to be at 2008. But in linked list, it can be anywhere. It can be any address. It can be 5000, 6000 or up, down, anywhere, right? So that's the thing about linked lists. They can be at any random locations. What are the advantages you get with this? You can insert in the middle, you can delete from the middle, you can insert at the beginning, delete from the beginning more efficiently. I'll just have to change few links to insert an item in the middle. But in arrays, I had to move everything one position down. One more advantage we get is we do not have to pre-allocate memory for any number of items. Say in arrays, if we were going to have 100 items, we had to pre-allocate the memory. And if we were removing some items, that memory was being wasted. What happens in linked list? If you have n items to be stored, you will have n nodes in memory. You will not have n plus 1, n plus 2 or n plus 3, right? You have exactly as many nodes required, right? You would not pre-allocate any extra memory. Why would you? Because you can randomly link them by dynamically allocating memory for the nodes. So that's the advantage of linked list. These two are main advantages: insertion, deletion, and no extra node required, no pre-allocation of extra nodes.